Light.
Light or visible light is electromagnetic radiation within the portion of the electromagnetic spectrum that is perceived by the human eye. Visible light is usually defined as having wavelengths in the range of 400 to 700 nanometers, nm, corresponding to frequencies of 750 to 420 terahertz, between the infrared, with longer wavelengths, and the ultraviolet, with shorter wavelengths.
The topic light in overview. Refraction.
In physics, refraction is the redirection of a wave as it passes from one medium to another. The redirection can be caused by the wave's change in speed or by a change in the medium. Refraction of light is the most commonly observed phenomenon, but other waves such as sound waves and water waves also experience refraction.
Wavelength.
In physics, the wavelength is the spatial period of a periodic wave, the distance over which the wave's shape repeats. It is the distance between consecutive corresponding points of the same phase on the wave, such as two adjacent crests, troughs, or zero crossings, and is a characteristic of both traveling waves and standing waves, as well as other spatial wave patterns.
The topic wavelength in overview. Radiation.
In physics, radiation is the emission or transmission of energy in the form of waves or particles through space or through a material medium. This includes electromagnetic radiation, such as radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma radiation, gamma.
Spectrum.
A spectrum, plural spectra or spectrums, is a condition that is not limited to a specific set of values but can vary, without gaps, across a continuum. The word was first used scientifically in optics to describe the rainbow of colors in visible light after passing through a prism. As scientific understanding of light advanced, it came to apply to the entire electromagnetic spectrum.
The topic spectrum in overview. X-ray.
An X-ray, or, much less commonly, X-radiation, is a penetrating form of high-energy electromagnetic radiation. Most X-rays have a wavelength ranging from 10 picometers to 10 nanometers, corresponding to frequencies in the range 30 petahertz to 30 exahertz, 30 times 1015 Hz to 30 times 1018 Hz, and energies in the range 145 eV to 124 keV.
Electromagnetic spectrum.
The electromagnetic spectrum is the range of frequencies, the spectrum, of electromagnetic radiation and their respective wavelengths and photon energies.
Infrared.
Infrared, IR, sometimes called infrared light, is electromagnetic radiation, EMR, with wavelengths longer than those of visible light. It is therefore invisible to the human eye. IR is generally understood to encompass wavelengths from around 1 mm, 300 GHz, to the nominal red edge of the visible spectrum, around 700 nanometers, 430 THz.
Visible spectrum.
The visible spectrum is the portion of the electromagnetic spectrum that is visible to the human eye. Electromagnetic radiation in this range of wavelengths is called visible light or simply light. A typical human eye will respond to wavelengths from about 380 to about 750 nanometers. In terms of frequency, this corresponds to a band in the vicinity of 400 to 790 terahertz.
Ultraviolet.
Ultraviolet, UV, is a form of electromagnetic radiation with wavelength from 10 nanometers, with a corresponding frequency around 30 pHz, to 400 nanometers, 750 THz, shorter than that of visible light, but longer than X-rays. UV radiation is present in sunlight, and constitutes about 10% of the total electromagnetic radiation output from the sun.
Sunlight.
Sunlight is a portion of the electromagnetic radiation given off by the sun, in particular infrared, visible, and ultraviolet light. On Earth, sunlight is scattered and filtered through Earth's atmosphere, and is obvious as daylight when the sun is above the horizon. When direct solar radiation is not blocked by clouds, it is experienced as sunshine, a combination of bright light and radiant heat.
Michael Faraday.
Michael Faraday, September 22, 1791 to August 25, 1867, was an English scientist who contributed to the study of electromagnetism and electrochemistry. His main discoveries include the principles underlying electromagnetic induction, diamagnetism, and electrolysis.
Photon.
A photon, from ancient Greek phi omega tau, phos, photos, light, is an elementary particle that is a quantum of the electromagnetic field, including electromagnetic radiation such as light and radio waves, and the force carrier for the electromagnetic force. Photons are massless, so they always move at the speed of light in vacuum, 299792458 m/s, or about 186,282 ms/s.
The topic Photon in overview. Quantum electrodynamics.
In particle physics, quantum electrodynamics, QED, is the relativistic quantum field theory of electrodynamics. In essence, it describes how light and matter interact and is the first theory where full agreement between quantum mechanics and special relativity is achieved. QED mathematically describes all phenomena involving electrically charged particles interacting by means of exchange of photons and represents the quantum counterpart of classical electromagnetism, giving a complete account of matter and light interaction. In technical terms, QED can be described as a perturbation theory of the electromagnetic quantum vacuum.
The topic Quantum electrodynamics in overview. Dirac delta function.
In mathematics, the Dirac delta distribution, also known as the unit impulse, is a generalized function or distribution over the real numbers, whose value is 0 everywhere except at 0, and whose integral over the entire real line is equal to 1. The current understanding of the impulses is a linear functional that maps every continuous function to its value at 0, or as the weak limit of a sequence of bumped functions, which are 0 over most of the real line, with a tall spike at the origin.
Boson.
In particle physics, a boson is a subatomic particle whose spin quantum number has an integer value, 0, 1, 2. Bosons form one of the two fundamental classes of subatomic particle, the other being fermions, which have odd half-integer spin, 1, 2, 3, 2, 5, 2. Every observed subatomic particle is either a boson or a fermion. Some bosons are elementary particles and occupy a special role in particle physics, unlike that of fermions, which are sometimes described as the constituents of ordinary matter.
The topic Boson in overview. Bose-Einstein statistics.
In quantum statistics, Bose-Einstein statistics describes one of two possible ways in which a collection of non-interacting, indistinguishable particles may occupy a set of available discrete energy states at thermodynamic equilibrium. The aggregation of particles in the same state, which is a characteristic of particles obeying Bose-Einstein statistics, accounts for the cohesive streaming of laser light and the frictionless creeping of superfluid helium.
Gauge boson.
In particle physics, a gauge boson is a bosonic elementary particle that acts as the force carrier for elementary fermions. Elementary particles, whose interactions are described by a gauge theory, interact with each other by the exchange of gauge bosons, usually as virtual particles.
Higgs boson.
The Higgs boson, sometimes called the Higgs particle, is an elementary particle in the standard model of particle physics produced by the quantum excitation of the Higgs field, one of the fields in particle physics theory. In the standard model, the Higgs particle is a massive scalar boson with zero spin, even, positive, parity, no electric charge, and no Koehler charge, that couples to, interacts with, mass.
Massless particle.
In particle physics, a massless particle is an elementary particle whose invariant mass is zero. The two known massless particles are both gauge bosons, the photon, carrier of electromagnetism, and the gluon, carrier of the strong force. However, gluons are never observed as free particles, since they are confined within hadrons.
Electromagnetic radiation.
In physics, electromagnetic radiation, EMR, consists of waves of the electromagnetic field, propagating through space, carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared, visible, light, ultraviolet, X-rays, and gamma rays. All of these waves form part of the electromagnetic spectrum.
The topic Electromagnetic radiation in overview. Vacuum.
A vacuum is a space devoid of matter. The word is derived from the Latin adjective vacuus for vacant or void. An approximation to such vacuum is a region with a gaseous pressure much less than atmospheric pressure. Physicists often discuss ideal test results that would occur in a perfect vacuum, which they sometimes simply call vacuum or free space, and use the term partial vacuum to refer to an actual imperfect vacuum as one might have in a laboratory or in space.
Electromagnetic field.
An electromagnetic field, also EM field or EMF, is a classical, i.e. non-quantum, field produced by accelerating electric charges. It is the field described by classical electrodynamics and is the classical counterpart to the quantized electromagnetic field tensor in quantum electrodynamics. The electromagnetic field propagates at the speed of light. In fact, this field can be identified as light, and interacts with charges and currents.
Electromagnetism.
Electromagnetism is a branch of physics involving the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles. The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic fields, and it is responsible for electromagnetic radiation such as light.
Blackbody radiation.
Blackbody radiation is the thermal electromagnetic radiation within, or surrounding, a body in thermodynamic equilibrium with its environment, emitted by a black body, an idealized opaque, non-reflective body. It has a specific, continuous, spectrum of wavelengths, inversely related to intensity, that depend only on the body's temperature, which is assumed, for the sake of calculations and theory, to be uniform and constant. A perfectly insulated enclosure, that is in thermal equilibrium internally, contains black body radiation, and will emit it through a hole made in its wall, provided the hole is small enough to have a negligible effect upon the equilibrium.
The topic Blackbody radiation in overview. Planck's law.
In physics, Planck's law describes the spectral density of electromagnetic radiation emitted by a black body in thermal equilibrium at a given temperature T, when there is no net flow of matter or energy between the body and its environment. At the end of the 19th century, physicists were unable to explain why the observed spectrum of black body radiation, which by then had been accurately measured, diverged significantly at higher frequencies from that predicted by existing theories.
Max Planck.
Max Carl Ernst Ludwig Planck, German, Max Planck, listen, English, April 23, 1858 to October 4, 1947, was a German theoretical physicist whose discovery of energy quanta won him the Nobel Prize in Physics in 1918. Planck made many substantial contributions to theoretical physics, but his fame as a physicist rests primarily on his role as the originator of quantum theory, which revolutionized human understanding of atomic and subatomic processes.
Albert Einstein.
Albert Einstein, Einstein, German, Albert Anton, listen, March 14, 1879 to April 18, 1955, was a German-born theoretical physicist, widely acknowledged to be one of the greatest and most influential physicists of all time. Einstein is best known for developing the theory of relativity, but he also made important contributions to the development of the theory of quantum mechanics.
The topic Albert Einstein in overview. Photoelectric effect.
The photoelectric effect is the emission of electrons when electromagnetic radiation, such as light, hits a material. Electrons emitted in this manner are called photoelectrons. The phenomenon is studied in condensed matter physics, and solid-state and quantum chemistry to draw inferences about the properties of atoms, molecules, and solids.
Planck constant.
The Planck constant, or Planck's constant, is a fundamental physical constant of foundational importance in quantum mechanics. The constant gives the relationship between the energy of a photon and its frequency, and by the mass-energy equivalence, the relationship between mass and frequency. Specifically, a photon's energy is equal to its frequency multiplied by the Planck constant.
Speed of light.
The speed of light in vacuum, commonly denoted c, is a universal physical constant that is important in many areas of physics. Its exact value is defined as 299792458 meters per second, approximately 300,000 kilometers per second or 186,000 ms/s. According to the special theory of relativity, c is the upper limit for the speed at which conventional matter, energy, or any signal carrying information can travel through space. All forms of electromagnetic radiation, not just visible light, travel at the speed of light.